It is time to continue Chapter 7 here with some more inverse trig functions, but in 7.2. So remember the end of the last lesson? That's what we're going to be doing today here, as you can already see at the bottom of the screen. So a quick refresher as to where our inverse, sine, cosine, and tangent is positive would be our first quadrant. Inverse sine and tangent are going to be in the fourth quadrant there. And then for negative values. And then our cosine, our inverse cosine function will be negative in the second quadrant. So we got to remember that our answers are going to come from those quadrants. We're going to position triangles in those quadrants. Let's just do it. Alrighty. Find the exact value of tangent of inverse sine of 1/2. I'm going to favor drawing out triangles in this one rather than the unit circle, and you will see why when we get towards the end. Alrighty. So for this one, let's see here. I'll just go with blue. So I'm going to work from the inside out. All right. Inside out. Okay. So inside, meaning for what angle does sine equal 1/2, right? Well, let's position it. Let's draw it up. Sine is opposite over hypotenuse, so that's a weird, not a very right. There we go. I like it. So opposite hypotenuse, right? Everything's positive. I'm in the first quadrant. I know this is going to be √3. Well, what would my angle be there? That would be a pi over 6. So I'm thinking, what's tangent of pi over 6? But do I really even care by that? Because I'm just going to draw up the same triangle to get my tangent, right? Cool. So I've got 1 over √3. So I've got, now I'm doing tangent of pi over 6, and I've already got my triangle drawn up. And that'd be 1 over √3. That is a terrible 3. And if I rationalize that √3 over √3, I'm going to get √3 over 3. Again, I'm having troubles with my 3's here. There we go. There's my solution. √3 over 3, right? We're within our domain for our inverse sine. That's between negative pi over 2 and pi over 2. First quadrant, all's good. All's right with the world. Awesome. Let's move on. Let's keep going. Okay. So sine of inverse cosine of negative √3 over 2. Inside out, right? Well, cosine, where's cosine negative? Our inverse cosine function is defined in our first and second quadrant. It's negative in that second. So I'm going to draw this one up in my second quadrant. And cosine is adjacent over hypotenuse, and then I know that that's 1. So my 30, 60, 90 triangle, and I'm sure my 45, 45, 90 triangles will come into play here. Okay. So I know that this would end up being, just for fun, this angle of rotation is 5 pi over 6, right? Cool. So then what we're asking ourselves is, so since this right here is 5 pi over 6, what is sine of 5 pi over 6? Well, I've already got my triangle drawn up. Why even bother with the unit circle if I've already drawn this, right? Well, sine is opposite over hypotenuse, so that is 1/2 for my final answer. Awesome. So as you can already see now, the triangles have quite the advantage, and even more so later, as I've already referenced. So let's keep rolling with it, shall we? All right. Oh boy. Oh boy. We've got reciprocals coming our way. Look out. Look out. Woo! Secant of inverse sine of negative √2 over 2. Sine, the inverse sine is going to be negative in our fourth quadrant, right? How we defined it. And I'll go ahead and just draw that up. We're working from the inside out. So what is that? Well, opposite is going to be negative √2, 2, and this is going to be √2 as well. All right. But really, you know what might be a little bit more clear, I think, in this one is if you draw, I think we know that this is a 45, 45, 90 triangle, right? We know that's a 45 reference. I'm going to draw it up as such with negative 1, 1, and √2. I like that much better, right? I like that a whole lot better. Okay. Lovely. Wonderful. Fantastic. So this is my, I know this is negative pi over 4. So you could think about that as negative pi over 4. So I'm wondering what's the secant of negative pi over 4. But again, I've already got the triangle drawn up. I'm already ready to go. Secant is hypotenuse over adjacent, right? Choshikao. Sha is the one that we're dealing with there. So hypotenuse, which is √2 over my adjacent, which is 1. So just √2. 2 for my solution. Lovely. Fantastic. Triangles, triangles, triangles here. Maybe I'll pop in the right angle there. My apologies, okay? Let's keep rolling. Next one. Cosecant of inverse tangent of -1. Okay, so tangent, the inverse tangent function is negative in the fourth quadrant, right? So it's restricted to. So I'm going to go ahead and draw that. So you can think of this as -1/1. And if I draw that triangle, opposite, adjacent, that is a root 2, right? I recognize it. So it's a 45, 45, 90 triangle. Okay, so this is going to be -pi/4. That's what that is. But do I really care? I've already got my triangle drawn. So what's the cosecant of that angle? Well, cosecant of an angle is hypotenuse over opposite, shikao, right? Hypotenuse is root 2. So cosecant of -pi/4. I'll go ahead and write it since we have it. Is going to be hypotenuse over opposite. So that would just be -root 2 for my final answer. Lovely. All right. Now, I believe our next part here is going to be, well, what about if we aren't dealing necessarily with nice 30, 60, 90, 45, 45, 90 special right triangles? Well, lucky for you guys, I do know how to deal with that. Where did it go? There it is. So let's get after it. I'm going to show you my ways, but first I'm going to get a little hydrated. That's a lot of talking, a lot of math, a lot of good stuff. All righty. So sine of inverse tangent of 1/2. Now 1/2 you might be like, oh, that is a nice one if it's cosine or sine, but not with inverse tangent. Okay. So let's see here. I'm going to draw up a triangle, right? I want to know what angle would give me 1/2. So if I draw my triangle, well, it's positive. It's going to be in the first quadrant. Opposite over adjacent. Maybe I'll draw it a little better. Oops. Or not. 1 sec. And there we go. 1. And then adjacent is 2. Again, that's not a nice one, so I'm going to have to do a little Pythagorean theorem. 1 squared plus 2 squared is equal to c squared. So that'd be 5. And then I'll take the square root on both sides. So it's just going to be root 5. That's not even going to simplify. And I'm not obviously not going to deal with the negative because it's my hypotenuse. Alrighty. Lovely. Wonderful. Cool. So this is my angle theta. Now I want to know what is sine of that theta, because I don't know what the angle is. I don't really care because I'm just going to find the ratio anyways. Well, sine is going to be opposite over hypotenuse. And I'm going to have to rationalize that bad boy. And I'm going to get root 5 over 5. Awesome sauce. Coolio. I like it. Very good. It's all about positioning it, right? It's positive in the first quadrant. Yeah, tangent's also positive in the third, but it's not defined. Our inverse is not defined in that third quadrant, right? So we're only dealing with the first when it's positive. Now let's take a look at number 6 here. For number 6, now this blue is getting monotonous here. I'm going to go with a little. I'm going to go green. Green is my favorite color. Jot that down. That's important. Cosine of inverse sine of -1/3. So inside out, if I'm going to position this, my inverse sine function is defined here in the fourth quadrant when it's negative. Opposite is -1. Hypotenuse is 3. This is not a nice right triangle. This is not a special right triangle. This is not triples or anything like that, like the 3, 4, 5, 5, 12, 13, so on and so forth. So I'm going to have to Pythag it. So -1 squared plus, I'm going to call it x squared because it is this right here is my x value. It's on my x-axis. So I'm going to go with x equals 3 squared. And then I'm going to have x squared is equal to, 9 minus 1 is 8. So x, once I take the square root on both sides, I'm going to get 2 root 2. So that's 2 root 2 for that side. Okay, and this is my angle theta. Now, what's the cosine of theta? Right, because I just found the angle, right? Sort of, I drew it up. Well, what's the cosine of that? Well, that'd be adjacent over my hypotenuse. And what's done is done there. We're done on that one. A couple more examples, though. Don't you worry. Whoop, whoop. Okay. So, last one, or last couple here. We've got tangent of inverse cosine of negative 1/3. Okay, so I love this because it's just the same number as the last one, except for since it's inverse cosine, we're working inside out, right? Start with the inside. Cosine is negative over here. So I'm going to have negative 1 here, and I'm going to have 3 here, but I already know from the last problem, this is going to be 2 root 2, right? Why do it again? Why do the pi that again? I mean, it's so much fun, but I'm just going to save some time. Okay. This is my, whoop, cool. There's my reference. So tangent of that. Well, tangent is equal to my opposite, which is 2 root 2 over my adjacent, or negative 2 root 2 once we simplify it. Nice. We are just absolutely cruising on these problems. I'm loving it. I love drawing triangles. Whew. Number 8 here. Uh-oh, what the heck is going on here? Inverse cosecant of 2. This scares me because we just have a number, just 2. It's not even a fraction. Oh, wait. Oh. Over 1. Whew. I feel much more warm and fuzzy inside now that I've put that over 1. That was close. All right. How about just because I've been dealing with the inverse on the inside the whole time here, I'm going to draw the triangle, shall we? Let's do it. Cosecant is the reciprocal of sine, right? So it's going to follow the same positive and negative scheme as sine. So if this was a negative 2, I'd be in the 4th quadrant, but it is positive, so we're just in the 1st quadrant, right? But keep in mind, cosecant of an angle is hypotenuse over opposite. Cho, hypotenuse over opposite. So my hypotenuse is 2, and my opposite is 1. Woo! I know those values. This is a root 3 here. This is a 30 degree or pi over 6, right? It's a 30, 60, 90 triangle. So pi over 6 is my solution on this problem here, right? We were just asked for the angle on this one. Oh, a little curveball there at the end, don't you think? A little curveball thrown at us. We're like, wait, hold on a sec. You messing with me, man? Are we missing something? No, we were not. Okay, just keep me on your toes. I decided to add one last problem in here for you guys. It is a little more like what we had in the previous lesson, but it does come up on the homework, so I just wanted to refresh it. We're going to work from the inside out. All right, so what's sine of 7 pi over 4? Well, I'm going to deal with that first. So sine of 7 pi over 4, what's that going to equal? Well, if I draw that up, 7 pi over 4 swings all the way around here, and it's a 45-degree reference. So I'm going to think of this as negative 1, 1, and root 2. Right? Or you can look at it on your unit circle and you'll see that it is negative root 2 over 2. But if you're a special right triangle person like me, oh, I put a 3 there. I don't know why I did that. I'm going to rationalize it. And I know that this is negative root 2 over 2. So either way, we get that for the inside part. Now, well, inverse cosine of negative root 2 over 2. What's that? Well, we got to position that accordingly because inverse cosine is defined in the 1st and 2nd quadrants. Negative would be in the 2nd. So I'm going to draw that up. Right? And I know that this is going to then be negative 1, 1, and root 2. Right? I rationalize it to unrationalize it. That's a little weird, but whatever. And I know that this is going to end up being what angle of rotation? Well, that reference is a pi over 4 or 45. So this is going to be 3 pi over 4 for that one. All right. That would be my final answer for that particular problem. Awesome. Fantastic. Thanks for tuning in here this week for 7.2. I love me some inverse trig functions. Have a wonderful day. America, freedom, rock and roll. Costco, Riverdog Jenny on the gram. Deuces.